Imagine this. A patient rushes into the ER in a diabetic emergency. The treatment they get for the rest of their life could hinge on one simple question. Is it type 1 or type 2 diabetes? But what if that's the wrong question? It turns out there's a much smarter way to figure this out, using a framework called the A-beta system. And trust me, understanding it changes everything.
Okay, so let's dive right into a super high-stakes scenario. You've got a patient with DKA, or Diabetic Ketoacidosis. This is a really dangerous state where the body, literally starved for sugar, starts running on what is basically toxic fuel. The immediate puzzle for any doctor is, okay, is this type 1 or type 2? And you've got to get it right, because the answer dictates their entire treatment plan for years to come. So the key to cracking this case is something called the A-B classification system. And what's so cool about it is that instead of forcing this simple binary choice, it uses two key biological clues to paint a way more precise picture of what's actually going on inside the patient's body. All right, let's break this down. First up is the first clue, the A, and that A stands for autoantibodies. So what in the world are autoantibodies? Well, you can think of them as evidence of friendly fire. These are proteins that basically prove the body's own immune system has gone rogue and is mistakenly attacking the very cells in the pancreas that are supposed to be making insulin. Not good. Think of these as fingerprints left at the scene of a crime. We test for a whole panel of 5 specific ones. Now, the most common one we usually find is called GAD65. But here's the really important part. Finding even one of these is enough. It confirms the immune system is involved, and we call that patient A positive. And boom, right away, this gives us our first major fork in the road. If you're A positive, we're almost certainly looking at an autoimmune process, which is the classic hallmark of type 1. But if you're A negative, that tells us the problem is something else entirely, and it pushes us to investigate other causes. Okay, so we figured out if there's an attack, but now we need to know, how bad is the damage? And that brings us to our second clue, beta, which is all about measuring beta cell function. So how do we actually measure that? Well, we use this clever little marker called C-peptide. See, for every single molecule of insulin your pancreas makes, it also releases one molecule of C-peptide. So, by measuring the C-peptide in the blood, we get this really reliable picture of how much insulin the body is still cranking out on its own. It's like our little window into the factory's output. Now, this chart might look a little complicated, but the main takeaway is actually super simple. Just look at that top line. If a C-peptide level is below 0.3, it means the insulin factory is pretty much shut down. We call that beta negative. But any significant production above that level tells us there's still some function left, and that's beta positive. But hang on, this part is absolutely critical. You cannot test C-peptide while the patient is in DKA. It just won't work. The incredible stress on the body will temporarily shut down any remaining beta cell function, giving you a falsely low reading. The right time to test is actually a few weeks after they've recovered and they're metabolically stable. All right, so we've got our 2 clues, A for the autoimmune attack and B for the level of damage. Now, here comes the really cool part. Let's combine them and see the 4 totally distinct pictures that pop out. Because this is where the system's true power is unlocked. When you put these 2 pieces of data together, you move way beyond a simple type 1 or type 2 diagnosis. You get this much more nuanced, detailed understanding of what's going on with that specific patient. And here it is, the whole system laid out. This combination creates 4 different profiles, or phenotypes. Just follow the paths with me. Up top, you have A positive with beta negative function. That's your classic type 1. But check this out. A positive with beta positive function is different. That's an autoimmune process where the person still makes some of their own insulin. Then at the bottom, A negative and beta negative is a really rare idiopathic type. But here's the real twist. Look at A negative, beta positive. No autoimmunity, and the insulin factory still works. This is something called ketosis-prone type 2, a condition that looks a lot like type 1 at first, but biologically, it's a completely different beast. So this is all really fascinating biology, I get it. But why does all this detail actually matter for the patient sitting in the exam room? Well, it all comes down to being able to predict the future. The biggest takeaway is right here on this chart. This classification system helps us predict a patient's long-term need for insulin. Someone who is A plus beta minus, they're going to need lifelong insulin, no doubt about it. But get this, someone who is A minus beta plus, they might actually be able to stop taking insulin after the initial crisis is over and manage their diabetes with other treatments. I mean, that is a life-changing difference. And at the end of the day, that's what this is all about. The ABIS system takes diagnosis from just being a label and turns it into a roadmap. It lets doctors personalize care, manage a patient's condition with incredible precision, and set really clear, honest expectations for the road ahead. So think about it. This one system reveals 4 distinct types of diabetes, where we used to just see 1 or 2. It kind of makes you wonder, right? As our tools get even more precise, are we going to discover 6 types, or maybe 10? The A-B system is just a perfect example of how a deeper understanding of biology is changing medicine right before our very eyes.